All right, we are going to do our last little bit on our parent functions with Mrs. Fields Math. Now, the parent functions we have so far, 5 of them. We have our absolute value function, our quadratic function, cubic function, square root function, and our cubed root function. Not only do we have to know what these graphs look like, we have to know what they're called. We also have to know their actual parent function equation, and they're all on this slide. The absolute value, its parent equation is f of x equals the absolute value of x. You can see that right there. Now, to talk about its graph, it has a V shape. It's nice and pointed. Every V shape, nice and pointed, up or down, doesn't matter. It is going to be in the absolute value family. Our next one is a U shape. It is nice and smooth. It's the quadratic. F of x equals x squared. The third one we have is the cubic function. I say it's an S shape. It's kind of an elongated or stretched out S. The ends extend vertically. So one end goes up, one end goes down. That is our cubic function. F of x equals x cubed. Now we also have our square root function. I call, and that's f of x equals the square root of x. I kind of say, okay, it's a partial check mark. I start here and then I go off in one direction. Our fifth one that we already have is our cubed root function. F of x equals the cubed root of x. It is an S shape. It is kind of sideways. So our ends go off to the left and right, not up and down, but to the left and right. Okay, now we're going to talk about the equations of the parent functions again. Okay, the equation, absolute value, that's what it looks like. When you are asked for the parent function equation, this is what you want. This is what I want you to put on your paper. F of x equals the absolute value of x. Then we have f of x equals x squared. That's our quadratic. So whether I give you f of x equals x squared and you tell me it's a quadratic parent function, or I say what is the parent function of the quadratic parent function, and you write down f of x equals x squared. So either way, regardless, that is the parent function equation. We also have f of x equals x cubed, which is our cubic function. And then we have our f of x equals the square root of x, which is our square root function. And last but not least, we have our f of x equals the cubed root of x, which is our cubed root function. So these are all of the equations to the parent functions, okay? You need to have all these. We also talk about general form. This is the general form for our absolute value. Okay. We also have the general form for our quadratic function, and we have the general form for our cubic function, as well as the general form for our square root function and our cubed root function. So if you'll notice in all of these, we have an A, an H, and a K in every one of those general forms. You need to be familiar. You have to be familiar. So you need to make sure that your general form is copied down into your notes. What good is general form? Well, that is a great question. A is going to determine our vertical expansion or compression in every one of those. H will determine our horizontal shift, and K determines our vertical shift. Every single one of those had an A, an H, and a K. It's up to us to be able to look and identify them. Okay, determining the vertical expansion or compression. If A is between 0 and 1, a fraction or a decimal that has a value that is between 0 and the number 1, I will have a vertical compression. My output of my transformation will not be as high or as much as the output of our parent function. So the output is smaller. Okay, so a vertical compression tells us it's smaller. A vertical expansion would tell us it's bigger. So if our A value is greater than 1, it could be 1.1. It could be 5/4. 5/4 is an improper fraction. It actually has a value of 1 1/4. So that's greater than 1. So we would have a vertical expansion. My output of my transformation is larger than the output of my parent function. H determines my horizontal shift. Horizontal is a left or a right move. K determines my vertical shift. My vertical shift is up or down. The beautiful part, if we can identify A, H, and K, then we know what each one represents, then we can describe each and every one of our transformations. Okay? We can do them all. Now, what we're going to do, we're going to do this one. We're going to describe the transformations necessary to transform g of x from its parent graph. Well, the first thing we need to look at this, we're going to identify A, H, and K. Well, A is our coefficient out front. So A is 3. It's located right here. Okay. Now K. K is, no, not K. K's tacked on the back. H. H is a negative, or what we see is a -7. But H is actually a +7 because it's x minus h. Minus a negative would make it a positive. So I don't see a positive up there. So H is 7. K's tacked on the back, and that is exactly what we see, just like it is. It is a -5. Okay? Now, first thing that we're going to do, okay, well, not first thing, second thing. We've identified A, H, and K. So what we're going to do now is this is a quadratic function family. So we're going to list that first. Now, we're going to read left to right, even though we've already identified it. First thing we see is the 3. That is my vertical expansion or compression. A is greater than 1. So I have a vertical expansion by a factor of 3, and I need to say that. So I have a vertical expansion by a factor of 3. The next thing we see is our x minus 7. What's grouped with x? Now, x does have something grouped with it. That is the 7. So that 7 tells me I have a horizontal shift. Now, since it's a +7, I'm going right 7 units. So the next thing I list is a horizontal shift right 7 units. Now, continue reading. I see the squared, but we've already saw that. That's a quadratic function family. Then our K is tacked on the back. That's -5. So that gives me my vertical shift. Since it's -5, it's going to go down 5 units. Now, because this is a quadratic, because I had any type of shift, doesn't matter if it's a horizontal or vertical, I do have a vertex change. Now, a vertex, it could also be called a turning point, but we do have a change. So our vertex changed from 0, 0 to a +7 and a -5. That +7 is my h value. That -5 is my k value. So my vertex changed from 0, 0 to 7, -5. If I did not have a horizontal shift, I would still say it changed from 0, 0. With no horizontal shift, I would have 0, -5. Okay, so keep in mind if I have any type of horizontal or vertical shift, I do have a change in the vertex. And we have 2 functions that have axis of symmetry. Those are the absolute value and the quadratic. Since this is the quadratic, I do need to mention a change in the axis of symmetry. So last thing I ever mention is the axis of symmetry changed from x equals 0 to x equals 7. Now, all of your transformations are done in the same way. So we're going to try that. So the next one, you're going to try this one. So I want you to try this. Be sure that you answer the question. And we're going to continue to go. You might want to. Okay, we're going to get it again. Here it is again. What good is general form? Okay, what good is general form? A determines our vertical expansion or compression. H determines the horizontal shift. K determines your vertical shift. Okay, and remember that applies to all of them. So we're going to do another one. We're going to do this one. Okay, and I put over there, I put note, determine your vertical expansion or compression, your horizontal or vertical shift. Okay, in this case, we're going to identify our A, our H, and our K. Our A is a coefficient out in front of. A is 3/4. That is less than 1. So we're going to have a compression. Now, X plus 4 is grouped. Our radical sign is a grouping symbol. And remember, it is opposite of what we see. We see a plus 4, so H is a negative 4. K is exactly what we see tacked on the back. That is a positive 1. And again, describing the transformations, first thing we're going to list is the family. This is a square root function family. Next thing, we're going to mention our vertical compression or expansion. If we have one, and we do, we have A's 3/4, so we have a vertical compression by a factor of 3/4. We have an H value, which is a -4. The -4 tells me I'm going left 4 units. So we have a horizontal shift left 4 units. Last but not least, we have our K value, which is 1. It's tacked on the back. So that's a vertical shift up 1 unit. Okay. This is a square root function. A square root function we all have a starting point or a vertex or whatever. We do have shifts, so we need to talk about those. We already did, so we're going to list that our vertex or our starting point changed from 0, 0 to a -4 and a +1. In our square root function, we do not have an axis of symmetry. Therefore, we don't list it, don't mention it, we just go on. Okay? So, now, you're going to need to pause this because you're going to have to answer these questions just like before. Okay. You have one more that I want you to try. So you're going to need to pause it and do this one on your transformations. All right, we get our 2 new parent functions. These are the linear functions. We don't discuss our vertical expansion or compression, so to speak, on our linear ones. But you can see we have f of x equals x. It's just like y equals x. F of x and y are interchangeable. And this is our parent function going through the origin with the slope of 1. Our constant function, f of x equals 1, it's a horizontal line. Anytime you see a horizontal line, it will be the member of the constant function. As a matter of fact, the constant parent function is the only parent function that does not pass through the origin, okay? So now we're going to talk about the equations of those parent functions, okay? Our first one is f of x equals x. That's the linear function. We are more familiar, y equals mx plus b, or y equals x, okay? F of x is our function notation. That's a linear function. Our line goes through 0, 0 with the slope of 1. And again, our constant function, f of x equals 1. Okay, that's the parent constant function. Okay, now, when we describe transformations of our linear ones, we talk about slope and then the vertical shift or the y-intercept. Okay, when we are just describing our constant functions, on our constant functions, our slope doesn't change because they're always horizontal, but it will change where they go up or down from our parent function. And we have some examples to go through and look at. Okay, this next one here, I've graphed 2 lines. Okay, our first one is our parent function. It's in red. Our second one is in blue. So we do have a transformation. Now, if we look at this, our first one right here in red, our slope is found the coefficient of x, so our a value, but our slope is 1, and it passes through 0, 0. The y-intercept is 0. So if I compare the blue graph to the red graph, well, my slope changed from 1 to 1/2, so technically I was compressed. Okay, and then I went down 3 units. We don't talk about a horizontal shift on our linear ones, okay? So our slope changed from 1 to 1/2, and then we had a vertical compression. Okay, you could say I have a vertical compression by a factor of 1/2. I would probably just say the slope changed from 1 to 1/2, and then I would say that the y-intercept changed from 0, 0 to 0, -3. All right, we're going to get f of x equals 1, our constant function right here. Our slope is 0. Every horizontal will always have a slope of 0. A horizontal line does not cross the x-axis. It might end up being the x-axis, but it doesn't just intercept the x-axis. It will always have a y-intercept because you'll note right here as our parent function, our y-intercept is 0, 1. If we look at our blue one, I went from the red line down to the blue line. So f of x equals -7. My slope is still 0, so there's no change in that. We don't mention. We can say, okay, k's tacked on the back. It's a -7. Well, we can say that our y-intercept is a -7, but we had a vertical shift down 8 units because I started at 1. I started at 0, 1. So I went down 8 units. So vertical shift down 8 units, y-intercept changed from 0, 1 to 0, -7. Okay, we're going to do this, this one in particular one together. Again, I put little notes up there on what we're supposed to mention. This is a linear, it's not a constant one. So g of x equals 3/4 x plus 5. So my slope is 3/4, which is less than 1. So I'll have a compression, or my slope changed from 1 to 3/4. My k value, which is tacked on the back, is the number 5. That's my y-intercept. My y-intercept is 5. So the very first thing that I'm going to mention what family it is. This is the linear function family. Okay, my slope changed from 1 to 3/4. My y-intercept changed from 0, 0 to 0, 5. Okay, so it did change from 0, 5, or to 0, 5. This next one, we're going to do this one as well. Okay, g of x equals 8. We're going to describe the transformations. This is a constant function. That means I have a 0 slope. I just go left and right. Okay, so slope is 0. Every single constant function has a slope of 0. Okay, my k is 8. In other words, it's going to go through 0, 8. So from my parent function, f of x equals 1, to my new one, g of x equals 8. Well, I only went up 7 units. I do need to say, okay, it's my constant family. I had a vertical shift up 7 units, okay? My y-intercept changed from 0, 1 to 0, 8. And again, the reason why the function shifted up 7 units and not 8 units is because we started from 1, not from 0. Okay, you're going to try this one. Now you have 2 more. You're going to do this one and then one after this. So be sure and answer those questions. Pause the video because you're going to have to make your entries. Okay. We have one more. And once you answer this one, you will be finished. Don't forget to hit the turn in sign.